So cane toads are an invasive species. They were introduced to Australia in 1935, and since then they've spread all over the country. They have negative effects on our native wildlife. So snakes and goannas and quolls, for instance, trying to eat them get poisoned. And so it has negative effects on populations of those species. They are a nuisance. People don't like to see them in their backyard, and they can also poison pets. So in general, cane toads are a feral species that we don't need to have in Australia. Some of the solutions that had been suggested are still in the pipeline now, and people are thinking about high-tech ways of controlling toads, but there was no low-tech way of controlling toads except picking them up off the ground. And so ACTA approached me and wanted to work together to develop this trap. And that's been super exciting for me because I'm a scientist working away in my ivory tower. It's nice to be to meet people from industry, understand how they do things, understand how a trap like this is developed, and to have input so that the trap can be as effective as possible.
So there are three main components for the cane toad trap. The trap itself is basically a wire box with finger doors on three sides. The finger doors allow a toad to go in, but then can't exit the trap. Inside the trap, we've got a lure. Now this is the most important part of the trap because it plays a cane toad call on repeat and shines an ultraviolet light. So toads are attracted from the surrounding area in close to the trap by the call, and then they enter the trap to either get really close to the call or to eat the insects that are attracted by the ultraviolet light. The third component is a solar panel that charges the lure. So during the day, the lure is switched off, charges automatically, and then at night, it switches on. So there's no effort. You don't need to go out and turn the trap on or off. The solar panel does all the work for you.
A female toad really cares what the sound is like, and so we've spent a lot of time engineering the call to make sure that we attract females that are gravid, females that are carrying eggs, which are the ones we want to remove from the population because they have the future generation inside them. If we remove them, we can reduce the number of offspring available. So we've spent a very long time, over 15 years of research developing a cane toad trap, which is going to be released later this year, and which will be successful capturing cane toads. And that's fantastic. But there are other invasive amphibians all over the world. And some of them are large and much like toads in some ways. And therefore, I think as the next stage, we could adapt the trap to capture other sorts of amphibians. An example of another amphibian that would be important to capture would be bullfrogs. Bullfrogs are sort of the second big wave of amphibians that are sweeping across the world. And they're a problem for native fauna because they're voracious predators and they eat other frogs. And so they're a source of predation and mortality to other frogs. And they also carry frog disease, so it's amphibian chytrid fungus. And that fungus is spread by these frogs. So the more places they arrive in, the more they spread this disease. So they have two negative effects on native frogs. At the moment, there is, just like cane toads, there is no method of control for bullfrogs available at all. So again, people have fallen back on hand removing them. So the research that we hope to do in the future with respect to the frogs is to go to various places where these frogs occur and record their calls so that we have samples of what they sound like in nature. The next thing we need to do is modify those calls to make them attractive to female frogs. And then, of course, we'll need to go to those different places in the world and test the traps and ensure that they are attractive to females in the way that we expect and that we can remove gravid females from populations of frogs the way we can do to toads. So that's what our intention would be in the next section of this research. So this product can be used to control frogs in a variety of different kinds of places, wetland management, but also anywhere, parks, gardens, anywhere there's ponds, because bullfrogs are really water frogs. They tend to be much closer to water than toads are. And so it will be management of areas where they don't need invasive frogs eating their frogs, so sensitive areas would be important. And so anybody who wishes to get invasive bullfrogs out of their pond or wetland would be interested in using this product. And I think this will be the first tool in the toolbox for controlling bullfrogs worldwide.